So we continue with the further instruction set of 85. As stated that 85 is 8-bit processor, but it provides 16-bit instructions for what we can say efficient way of computing the things. So one more such important instruction is DAD, it is double addition. DAD, then as stated again, it is double addition. Addition requires two sources and one destination. So for 16-bit things, we already know that HL pair is having some special treatment. So for that, HL pair is one of the default sources as well as the destination. So it is that register pair. How many register pairs are there? BC pair, DE pair, HL pair and stack pointer. Stack pointer will come later, but there are 4 register pairs. So it is that RP wherein HL getting assigned to HL plus RP. Is it correct or some correction is needed? Whatever we have written there, is it correct and complete or some correction, some small change is needed? Right. So addition of two 16-bit number has to be a 17-bit number. So carry flag and HL becomes HL plus RP, right? This is DAD B, DAD D, DAD H, DAD SP. 4 DAD instructions are there. And there is one more instruction, that is only one such one, peculiar one, exchange. Otherwise, doing exchange is very difficult. If you want to exchange register B and register C, you can't do so because you have to take help of some other register. By move, or it is lost, or you have to keep it in at some memory location which is not used for any other purpose, and then you can do it. Are you getting me? Exchange, even though quite simple, it's a very means there is nothing, means it's a data transfer instruction. It's a bi-directional data transfer, but achieving it without such instruction is not so easy. So there is one exchange instruction that again is providing a somewhat easier way of programming. Remember that there are many means. In fact, actually a task can be there out of the instructions that identify you. How many instructions are redundant that you can find out. Means redundant means what? That task which is done by that instruction can be done by other instructions. Maybe it will take some more instructions to do. So we are having few such instructions. So out of 74 instructions, many can be said to be redundant in the sense they increase the richness, but even if those are not there, means just like you can have fast in some kind of season, or you can say that I will not eat, means there are some limited fast, means what you do is that it's not that you don't eat anything, you consume something, but only out of that limited set. So like that 85 instruction set you can find out what is the instruction which is bare minimum required. That can be a good task. So the exchange, one more instruction, it exchanges D and HL pair. So what must be happening inside? What must be happening inside? 1 byte instruction, both operands, source and destination are inside. So it gets executed at once, no more cycles needed. But what must be happening inside? Can you guess?
Data from HL is stored in DE pair.
And?
It is stored in DE pair. DE pair data will enhance.
So if you do that, what about it? It is exchange. So if you put HL to DE, then all D will be lost. So how that must be performed? Some must go to WZ, say D must go to WZ, then what you say that HL must come to D, and then WZ should go to HL. Is it right? Is 1 byte instruction. No more cycles needed, but internally something will happen like this. Is it okay? So DAD register pair and exchange. So now with this, we will write the same program which we did last time. What is that? Write a program for 16-bit addition where first number is in 8000 and 8000 1. Second number is 8002 and 8003, and result in 8004, 8005 and 8006. So we can write this program in very small number of instructions now. Last time we discussed how it can be done using add. Then the issue of carry was there. So that time we have not learned add with carry instruction. Then we learned add with carry instruction and found out how the task becomes simplified. Now we are having double addition, DAD. So that makes the things very simple. So write a program to add two 16-bit numbers stored at 8000 and 8001, add and 8002 and 8003, and store the result of the addition at 4, 5 and 6. So the instructions to be used are obviously DAD. Then so I write on this side, we have to use DAD, we have to use exchange for effective, LHLD, SHLD, jump on no carry, and say MVI, a something. So using these instructions, you should be able to write the program. Since we are having shortage of time, we can't afford asking you to complete the program. So I write and you try to understand simultaneously with it. So it is like this. MVIA 00, STA 8006, LHLD 8000, exchange LHLD 8002, DAD SHLD 8004, jump on no carry skip, MVIA 01, STA 006, skip all. So now I would like that everybody of you should be able to convince themselves. What is the classroom task? Convincing that finding answer we don't have that much time. Otherwise, if it is to be time is to for everybody, most of them should complete. That much time we can't afford right now, at least in the coming 2 weeks. So we should be able to understand now. I have written the program, some kind of reverse engineering. Means you should be able to convince yourself that yes, it is the answer to the problem question asked. Is it right? So let us go instruction by instruction. MVI 00 ST 8006. What does it do? And it assumes that carry will not come and stores 00 at the most. The addition of two 16-bit numbers is 17-bit number. 17-bit number takes 3 bytes for getting stored in memory. So the most significant third byte is made 0, assuming that carry will not come. If carry doesn't come, our assumption is correct and we are done with. If carry comes, then our assumption is wrong. We have to correct. Is it okay? Right. Then LHLD 8000, what it will do? LHLD 8000. It will bring the contents of 8000 into L register and 8001 into H register. Right? Then exchange. What exchange will do? HL will be put to D and D will be put to HL, which is redundant. Right now it's of no use to me. But what means? What is my prime requirement right now? To transfer D to HL. Exchange does that and also transfers HL to D, which I am not required, which is redundant right now because I want to reload again HL. लक्षात आलं का? LHLD ने काय केलंय? 8000 आणि 8001 ला जो पहिला ऑपरंड आहे मेमरी मध्ये स्टोअर केलेला आहे 8000 चा LSB 8001 ला LSB, तो फर्स्ट ऑपरंड is taken into HL register. That is now transferred to D register. something which was old in D register that has come to HL register that I don't want, so I am again loading HL with 8002. So at this point of time, what is the scenario? When LHLD 8002 is executed, HL contains source 2, that is whatever is that 8002 into L, whatever is that 8003 into H. And what D contains? D contains source 1. Is it right? Listen very carefully. LHLD 8000, source 1 comes to HL. Exchange. Source 1 goes to D and something which is irrelevant comes to HL. Means exchange, see, exchange does means moving HL to D, that's what I want, and I am using exchange instruction. So listen very carefully. If my requirement is only moving HL to D, then whether exchange instruction can be used or not. Listen, it's a very simple but critical question. What is my requirement? Requirement is to transfer HL to D. So can I use exchange instruction? Whether exchange instruction does whatever I intend to, what is my requirement? Listen very carefully, it's very important. That 885 is now obsolete, but the principles are, what we can say, will remain forever. My requirement is to HL to be transferred to D. There is no instruction for that, not single instruction. Otherwise, we have to go for move E, L, move D, H. That you can do, but not a single instruction is there. So I have exchange instruction. Exchange does whatever is required to me. Means, suppose if I have one task and I have some instruction, whether that instruction can be used is to be decided by whether instruction does that what I require. The answer is yes. So the instruction doing the thing which I intend is a necessary condition, but is it sufficient? That is to be decided by the instruction does what I intend to, also the instruction does something else. Now whether, listen very carefully, whether the instruction which is doing something else than I require can be used, that depends upon further question. What is that? Instruction does something more than what I require. I simply require HL to D, but instruction also puts D to HL. Then can I use that? Answer not obvious, yes. In this case it is, but what is the condition which must be fulfilled before I do that? No, that you don't know. Instruction is doing something more. समजा आता तुम्हाला 885 शिकवायचंय आणि मी शिकवायला आलो आणि 885 शिकून आणखी भरपूर काहीतरी शिकवलं, मग ते चालतंय का? ते कधी चालेल? Additional जे काही आहे, that should not be harmful to you. Whether useful or not is independent. At least it should not be I am doing something else. If that is redundant, there is no problem. But if it is harmful, it should not be used. It should not be there. So exchange also puts D to HL. It disturbs HL. मला काय पाहिजे आहे? HL to D मध्ये न्यायचंय मला. पण एक्सचेंज काय करणार आहे? D ते HL मध्ये आणणार आहे. म्हणजे HL डिस्टर्ब होणार आहे. ते मला चालणार आहे का, मला चालणार आहे का, तर मी याच्यामध्ये आता काय करणार आहे, म्हणजे अगदी सोपं बघा. जेव्हा आपण 8 बिट काय केलं, LDA केलं पहिल्यांदा, LDA 1000, नंतर काय केलं, मूव A to B, बरोबर. आणि नंतर काय केलं लगेच, लक्षात इन्स्ट्रक्शन बघा, 8 बिट ऍडिशन, LDA 1000, मूव B, A, नंतर LDA 8001. इज इट राईट? म्हणजे अॅक्युम्युलेटर मध्ये हे झाल्यानंतर मला इथं काय करायचंय, अॅक्युम्युलेटर मला नवीन स्टोअर करायचंय. म्हणजे इथं काय, इथं मी काय करणार आता, LHLD करणार, म्हणजे मी HL मध्ये नवीन लोड करणार आहे. म्हणजे एक्सचेंज इन्स्ट्रक्शन म्हणजे चुकून काहीतरी अनावश्यक केलेलं आहे, ते मला हार्मफुल नाही. इज इट क्लिअर? Exchange instruction brings D to HL which is not required by me. But since HL, my purpose now is to again reload HL with new data. So when before I actually perform addition, I am reloading. So the exchange instruction also disturbs HL, which I don't bother because I am immediately reloading it. Is it clear? Therefore, exchange use is permitted. If that is not, then you should have done move E, L, move D, H. Then LHD 1002, what is the case now? Source 2 is in HL, source 1 is in D. So that D, what will happen? HL equal to HL plus D. So where are the least 2 bytes of addition? In HL itself. That I will store at 8000. 4 and 5. Then jump on the carry skip. If carry has not come, you will say, sir, you are doing one wrong thing. Which instruction will generate carry? That. So after that, you are not using the jump instruction. You are using one more instruction in between. Is it permitted? Where you have studied that? No, where you have studied it? Your 12th vocational? No. Then you have studied on your own? Then? Oh, so much more than where is my this one? What is your first name? Tushikesh. So since remember that data transfer instructions don't affect the flags. Don't affect means whatever is the state of all the flags before is continued. Then do you know the one data transfer which affects the flags? Data transfer instructions don't change the flags. So even if one instruction in between, still the flag condition will be corresponding to that instruction only. There is one data transfer instruction which affects the flag. What is that? Don't know. It is POP PSW. So those who are directly admitted have gone through my videos. If then they might find that something different is there than whatever they have learned. So whatever are the deviations are deliberate deviations so as to make the thing simple and not that I don't know the complicated things. So jump on the carry skip. If carry doesn't come, I am done with. And if carry comes, I make it 1 and I store again. Is it okay? In halt. It's 16 addition using DAD instruction. Okay. Right. Now let us move to next simple program. Write a program to multiply. It's very interesting now. Multiply two 8-bit numbers stored at 8000 and 8001. And what should be the space provided for the result? Two 8-bit numbers. And store and store the result at 8002 and 8003. Is it enough? That you can verify using FF into FF. What is the answer? F is 01. FF into FF is F is 01. So that tells that it is enough. So how will you proceed for that? So multiplication is to be carried out by what method? Successive addition. Now we have used that instruction. Use that instruction. So hint is take what is multiplication? Multiplier times multiplicand. Multiplier times multiplicand. Right? So put HL with 0, put D with 0, take one of the numbers in E, take one number you can take in A also, perform dash D for A times. That is the answer. So I write the program. NXIH0000, NVID00, LDA 8000, move A to E, LDA 8001, that D, decrement A, jump on not 0 again, otherwise SHLD 8002 and halt. Now just tell me whether this will perform the addition multiply appropriately. Just verify. It's very simple. It's very simple. There is no rocket science. First, LXIH. HL is result. In HL I am going to successively add. So 3 into 4 is 0. In 0 I add 3 for 4 times. Agreed? 3 into 4 means in 0 I add 3 for 4 times. So that HL I have taken made 0. I will be using that one of the dash instruction, that D, let us say. So DE is 16 bit. My multiplicand is 8 bit. So what I will do, I will put D as 0 and one number I will take in E, right? So D I have made 0. Is it okay? Now LDA 8000. So first number will come to accumulator. Then move E comma A. So what I have ensured by this instruction? By this instruction I have ensured that D contains multiplicand. D contains multiplicand. Am I correct? Is it okay? D contains multiplicand. Now what A contains? This is multiplicand. This is multiplier. Right? That D. In 0, add multiplicand for multiply number of times. Right? So that D, decrement A, jump on not 0 again. No question of how because D is 16 bit. So So there is no issue. SH, and when it is over, when A becomes 0, it will come out. SHLD 8002, it will store result 8002, that's all. Is it right? I think there is no rocket science, it's quite simple. But unfortunately, this program has got one mistake. No, the question of carry will not come because already there is 16 means the maximum number. What he pointed out is carry, but that is not the issue because a multiple of two 8-bit numbers, the maximum result FF into FF is FE01. So in not a single time carry will come after that instruction. But this has got one peculiar mistake that the answer will be wrong. What happened? Why is the problem? So DCRA normally we don't do, but it's not that it's wrong. Normally, in general in programming, if you will find, if a survey is met of 85 programs which you do in application for years together, decrement A is very rarely used because we use A for some other purpose normally, and therefore it is either B or C is normally used. But it is not that A can't be used. What you are doing, you are searching some program. Look here. So what I can say, even though I can't enforce the attention by making students to look at the whiteboard, at least we can reduce the probability of not, what we can say, distraction, right? The attention can't be enforced, but we try to reduce the probability of distraction. So that way disorder is not, it's not that it's wrong. There is very fundamental mistake. I think Ushika should be able to point it out. Where the program will go wrong. No? Now I will give an example. If 8000 contains 02 and 8001 contains 00, or let's say 01, it's very simple. What will happen? So in this case, what will happen? We are decrementing accumulator and then checking for zero flag. But if accumulator is already 0, then we decrement, it becomes FF. 0 when decrement becomes FF and 0 flag is reset. So it will perform the addition for 100 times, that is 256 times. So answer will be 0100. Answer will be 0100. So that is completely wrong. So we need to prevent that. How we can prevent that? So since we check it is after this, if it is already 0, it becomes FF and then it continues for FF 2 times. So we should check it before addition. So how can we do that? How can we do that? You have done this also, there also you have done. So you will before that.
First do that, then again this and again that.
No, that will double then.
Before that, JM,
Where?
before that,
Before that,
then skip to halt.
jump on,
Halt.
no zero, jump on zero.
Jump on 0.
So, it is jump on, zero, skip. And skip is
Halt.
not halt. Result will be stored. Result 00 which you have taken, it needs to be stored at 8023. अच्छा लगा? Not halt. We have to store result and halt. So this I will use by another ink. Another color, not ink. So is it okay? It's not so okay. Because you are using which instruction? Jump on zero, skip. So this, your logic is correct. The intention with which you are doing is correct, but the 885 architecture doesn't support that. What is the problem? So all you have said is correct, but it is not done. Merely because I say that I will study for 3 hours a day and plan it. If it doesn't get executed, it's of no use. What was the problem? Regarding the flags, in some different context, I have made a statement just a short while ago. What is that? Data transfer instructions don't affect the flags. So, right from the beginning till now, all are data transfer instructions. So, merely because A is 00, flag is not set 0. Means if 00 comes to accumulator as a result of data transfer instruction, flag doesn't become 0. Then what do we do? We have to use some arithmetical logic instruction. So by the way, I will take this opportunity to provide you 2 more instructions. Those are quite simple. Those are and ANA, ORA and XRA. It is any register or even here and or and XOR and B. What it does? And it's हे काय घेतलं नाही इतकं सोपं आहे की सगळ्यात सांगायचं शिकवायची गरज नाही. And register and B. Now you should tell me what you should do. And operation requires how many operands? किती source असतात? 2. Destination 1. ORing of 2 bitwise ORing of 2 numbers, 2 variables, 2 datas. Means source 1, source 2 and destination is 1. So since accumulator is a special register, in almost all arithmetic logic instructions, it is one of the default operands. So and R means what should happen? A equal to A and R. Or B means A equal to A or B. X or B means A equal to A XOR B. It is M also. What would be A and AM? A and AM and accumulator and a memory location given by HL pair and store result into accumulator. And in this case, the 0 flag is affected. Means if the result is 0, 0 flag becomes 1. If result is not 0, 0 flag becomes 0. If result is 0, 0 flag is set. If result is non-zero, 0 flag is reset. Now which instruction you will use? So LDA doesn't change the flags. After LDA you want to check whether accumulator is 0 or not. What instruction will do? ORAA or ANAA, because something odd with itself is that thing, something AND with itself is that thing, and that doesn't change also. So you can't use directly JZ skip. What you should do, and immediate ANAA, is it right? After LDA, ANAA, and then jump on 0, skip. Is it right? Is it okay? That's fine. Similarly, there are few instructions. We studied add. We studied add with carry. Subtraction I will not tell right now. I have deliberately kept it aside. Then I told you compare. This AND OR XOR. All are register oblique memory. Register oblique memory. Then for each of them there is similar instruction. Exactly same thing which I will not tell. Add ADI, ACI, CPI, ANI. You should tell me what it is. ORI and XRI. What this instruction should be? Now by common sense, even if though you are not either bifocal or DAs, still by common sense or by video watching, everybody must be able to tell what it is. What would be ADI? Add immediately. So it is how many byte instruction? 2 byte. Means add accumulator with the immediate operand and carry and accumulator will be the result. Is it right? Is it okay? So these also can be used. So here you can also use, like ANAA, you can use CPI 00. Compare accumulator with 0. If they are equal, we have told you means I have deliberately kept some instruction aside and discussed compare instruction. In compare, if accumulator is more, carry is reset, 0 is reset. If accumulator is set, if accumulator is less, carry is set, 0 is reset. If both are equal, carry is reset, 0 is set. So either you can use ANAA, ORAA or CPI 00 and then JZ skip. So that will take care that if the multiplier is already 0, if multiplier is already 0, in that case we don't repeat the things for 100 times, or FF plus means it is X 100 times. Is it right? If you don't take that care, then the answer will be wrong. Is it okay? Right. But this multiplication by successive addition is a childish method. Whether have you seen anybody nowadays with calculator, everything is now changed. But whether even pre-calculator era, whether multiplication was being done by successive addition method? No. It takes unnecessary huge time. So how multiplication is done? By how multiplication is done? (234) into 541, 542. So how do we do it? First, have partial products. 234 into 2, 234 into 4, 234 into 5. Multiply. Then this shift this two locations, shift this one location and add. Is it right? Multiply, shift and add. The fast multiplication algorithm does it by multiply, shift and add. It does by multiply, shift and add. However, when it comes to binary in bits, so instead of here what I am having, hex decimal number. So I am considering multiplicand as a whole. I am multiplying the multiplicand by different digits of multiplier and shifting and adding. मल्टिप्लिकँडला मी मल्टिप्लिकँड आहे का ठेवतो, मल्टिप्लायरचे डिजिट मी सेपरेट करतो, प्रत्येक डिजिटनं मल्टिप्लिकँडला गुणतो आणि ते प्रॉडक्ट शिफ्ट करतो, ऍड करतो. सो मल्टिप्लाय, शिफ्ट अँड ऍड. Now instead of this decimal, if I take binary itself, then in binary, multiply, shift and add will get reduced to what? Multiply, shift and add will get reduced to. Multiply will disappear because here multiplying was there because there were the multiply digit was between 0 to 9. But in binary, multiply digit is either 0 or 1. If it is 0, skip. If it is 1, take. Is it right? So shift and add. It is shift and add. It's very simple now. Now I will introduce 2 or 4 more instructions and then I will write the program, because we can't afford giving time and then that time is wasted, even though it gives very much mental exercise to you. We can't afford that. Maybe there is after medicine we can give heavy exercise. Means we can have a thinking chamber experiment. Put the students into the hall and allow them to leave only when they complete. Till then, keep them hosted in the same room. So the instruction is simple. Rotate accumulator left through carry. आता एकच घेऊया, बाकीचं नको. We only do one. Remaining you can do on your own, or sometime I explain. We don't spend time on something which is not required right now. Rotate accumulator left through carry. What it does? By name of the mnemonic which I uttered, it is simple. Rotate accumulator left through carry. Means what should happen? Accumulator. It is having bits, 8 bits. Accumulator bits are 8 bits. It is D7 to D0. Rotate accumulator left through carry. Which काय होणार? There is carry. 1 bit. Carry flat. Rotate accumulator left through carry means what should happen? D7 should come to carry and carry should go to D0. D0 go to D1. Is it clear? Rotate accumulator left means new carry is old D7. New D0 is old carry. New D1 is old D0. Like that, new D7 is old D6. लक्षात आलं ना? Rotate accumulator left through carry. Accumulator ची bits मानले left there. D7 goes to carry. D6 comes to D7. I hope it is quite simple and is now a question whether you understood or not is redundant because there is no option of non-understanding. It's quite simple. हे कळलं काय विचारणं म्हणजे मूळपण असतं. Are you agreeing with this? So now I write a program. Same program should be same. 8000, 8001. 2 numbers. Result is 8002 and 8003. I think I will write again because if I spill over, you may not understand. So I write it here. I'm just rewriting it. By that time, you may understand what is the purpose. So now, the multiplier and multiplicand. I say that E, that is 8000, contains multiplicand and 8001 contains multiplier. Now, what is the multiplication? Do we agree? Multiplication is 2 raised to n, 2 raised to 7 into m. I will say simple m here. And then multiplier into d7 of multiplier plus 2 raised to 6 m into d6 of the multiplier plus 2 raised to 5 m d5 of the multiplier plus 2 raised to 1 m d1 and 2 raised to 0 m d0. 2 raised to 0 is actually 1. So 2 raised to 0 is actually 1 and 2 raised to 1 is actually 2. Means 1 means that only MD0. Is it right? Shift and add method. Multiply, shift and add. It gets reduced to shift and add. 2 raised to 7 times the multiplicand if D7 is 1. Is it right? So multiplicand and this is D7, D0. What I will do? I will multiply this and shift by 7 times. Is it right? I will multiply this. This is not shifted. Then this is shifted by 1. This is shifted by 2. This is shifted by 3. So shifted by 1 means multiplying by 2. Shifted by 2 means multiplying by 4. Shifted by 3 bits means multiplying by 8. Means shifting by n bits is multiplying by 2 raised to n. Now, whether this program does that. So, when anybody understood it, is it doing it perfectly? Yes or no? मतलब न करण्यासाठी पहिली स्टेप कुठली आहे? म्हणजे न करण्यासाठी इन्स्ट्रक्शन म्हणजे प्रोग्राम मध्ये न करण्यासाठी इन्स्ट्रक्शन अर्थ असा की इन्स्ट्रक्शन कळल्याच पाहिजे सगळ्या प्रोग्राम मध्ये काय वापरले ते कळणार नाही. अशी कुठली इन्स्ट्रक्शन आता यामध्ये? पहिलं MVID00 का? ई मध्ये मल्टिप्लिकँड घेतलाय, ई मध्ये मल्टिप्लिकँड घेतलाय, म्हणून D00 डी मध्ये मल्टिप्लिकँड केला. HL मध्ये मी काहीतरी करणार आहे, HL 0 म्हणून घेतलंय, हे करते. हे सोपंच आहे. एक ई मध्ये नेलं D00 आहे, so D contains multiplicand, A contains multiplier bits, DE contains multiplicand, A contains multiplier bits, HL is made 0. In that I am going to work further. Now म्हणजे हे 8 का घेतला असेल MVID 08? 8 bits, right? So okay. 8 bits. Is it right? म्हणजे एक्झॅक्ट काय करते साधारणतः शिफ्ट अँड ऍड बिट्स वाइज करणार आहे. सो MVID 00 अंडरस्टँडिंग इज डन. MVIB 08 it's okay, not fully done but at least it's okay. LDA 8000 move A to E, LDA 8001 that's okay. DE is multiplicand, A is multiplier bits. LXI 00 that's okay. Why? There I am going to get the final sum. Now you might not understand म्हणजे which one? Dad का केलंय? का? Why? What dad does? त्यातच ते मिळवलं म्हणजे काय? What I intend to if I act, त्यातच ते मिळवायला काय मिळवलं असेल? Why I did that H? HL equal to HL plus HL आणि कॅरी येणार नाही का? मला रिझल्ट फायनली माहिती आहे की FF into FF is FE 01. So carry is not the issue. So why that H is being done? No. And even if your logic is stated to be correct, that vanishing means it happens in our life many times. Means suppose that you try to vanish your absence by asking somebody to put a proxy, but he is caught there, and that makes his life is along with you. It makes his life also miserable. So vanishing means the point to be said is that he is correct. Maybe even if we assume it is not correct actually, but even if you assume, we assume his logic is to be correct, to vanish something, what? Suppose if we intend to vanish something, we should ensure that the cost by the process with which we are vanishing that should not be more. So that is not the logic. So that is changes HL. So to